So today topic is rotational spectroscopy, and this is the given question. So they are asking us to find a vector diagram for vector diagram of angular momentum, which is the angular momentum will be this. Okay, so here omega equals to root 2 h cut. In this case, j equals to 1. Okay, so in order to find the vector diagram, so first we need to find out the degeneracy of this system. Okay, so whether it is a two-fold, three-fold, like that. So when j equals to 1, that time m ml, so in this case m equals to, sorry, j equals to l. So here the j value is equals to l value. Okay, now if j equals to 1 means l equals to 1. So if l equals to 1, ml values will be plus 1, 0, minus 1. So when this is the triply degenerate, or we can say threefold degenerate. So for threefold degenerate, the vector diagram will be like this. So this is a 1, this is plus 1, and this is a minus 1. Okay, so this is the vector diagram for when omega equals to root 2 h cut. So when we have a w equals to root 6 h cut, so in this case the j value will be 2. Okay, if you don't know the j value also, you can identify. So imagine that we doesn't know the j value is not given. So for we have to identify whether it is a two-fold, three-fold, five-fold, like that. So j value is not given, only this is given. So j value, how you will calculate? J into j plus 1. Okay, now imagine that this is the 1 plus 1, so this will be 2. 2 into 2 plus 1, this will be 6. So here j value is equals to 6. Okay, j value equals to 6. Now if j value is equals to 6, here j equals to l, so the ml values will be plus 2, plus 1, 0, minus 1, minus 2. So this is the fivefold fivefold means like it's having fivefold degenerate, we can say fivefold degenerate. And the vector diagram will be, this is 0, it will be like this. Okay, and this is 0, minus 1, minus 2, plus 1, plus 2. Okay, so we have to identify the means it's either it is a two-fold degenerate, three-fold degenerate by this way. And then so we know that the energy of a system of a diatomic molecule is equals to h square by 8 pi square I j into j plus 1. Okay, so from this this whole term is equals to b, rotational constant. So now ej equals to bj into j plus 1 centimeter inverse. Okay, this we know that. So when the j value is equals to 0, and that time the ej will be 0, because this will be uh, uh, this will be 0, this will be 0 plus 1 will be, sorry, this will be, it will be into 0, 0 plus 1, this will be 0. So when j value equals to 1, that e1 will be 2b. When j value is equals to 2, that e2 value will be 6b. And when j equals to 3, that time 3 into 3 plus 1, this equals to 12b. So like this we calculate the energy levels, and after that calculate the so we calculate the energy level like this. And if we see the diagram, so this is the 0b, 2b, 6b, 12b. As we can see here, the energy difference upon going from the bottom to top, the energy difference is increasing. So the why this energy difference is increasing, we'll see that. Okay, so imagine that this is a E0, sorry, this is E0 only, this is E1, E2 and E3. Okay, so the energy difference between these two terms will be E1 minus E0 is equals to 2b minus 0b equals to 2b. Whereas if you see the energy difference between E1 and E2, E2 minus E1 equals to 6b minus 2b, this is 4b. So if it is a 2b, and this, the energy difference between these two will be the double of this one, because it's 2b, 4b is the double of 2b, right? And now E3 minus E2 equals to 12b minus 6b, so this will be 6b in a centimeter inverse. As we are going from E0 to E3, the energy difference between the two the energy difference between these two like we can say that the energy difference is increasing here. This is 2b, this is 4b, and this is 6b. That's why as we go from the down to top, the energy difference between the two energy levels are increasing. Okay, so there is a one principle we have to calculate the energy difference, that is equals to del GE equals to 2b J plus 1. So either you can use this formula to calculate energy difference, or you can calculate by directly by this way also. No, it will be fine. So when you are calculating from 0 to 1, that time the J value always the least value. Okay, the J will be 0 here. So now del E equals to 2b 0 plus 1 centimeter inverse, this will be 2b. So when we are going from 1 to 2, in that case the J value is equals to 1, that will be 2 into 1, 1 plus 1, that equals to 4b. So either you can use this formula, so you will get same values, or you can follow this way also, as you comfortable. Okay, and then del E equals to 2b J plus 1. So how this is coming? Okay, so what is the del E? Del E is equals to the energy difference between the two energy levels. So that we can write as the two rotational energy levels, J plus 1 minus EJ. Okay, now this we can write it like this: B J plus 1 and then J plus 1 plus 1 minus this EJ will be BJ into J plus 1. So now it will be B J plus 1 and this will be J plus 2 minus BJ into J plus 1. Upon simplifying this, so this we can write like this, na? Like this also, this yeah, this we can write it like this. Upon simplifying, this will be del E equals to 2b J plus 1. So this is the means if you want to, like, it's not that difficult to remember. If you can't remember this one, you can follow this one. Okay, del E equals to del E J plus 1 minus EJ, and then these things will come. And now we know that at this level 0b 2b 6b 12b, so when energy equals to 0, is equals to 0, in that case the molecule is not rotating. So at this stage the molecule is not rotating, but when E equals to 2 at this, the molecule is rotating but the angle is very less here. As we go top, the molecule will rotate more faster. Okay, so these are the some important points. The problems will be asked based on these principles, this principle, and we'll solve some of the problems later after this, but these are the very important things we have to remember for a examination point of view. Next we have intensity of spectral lines. So here we have two concepts. First one is degeneracy, second one is the Boltzmann distribution constant. So according to the degeneracy, as the degeneracy increases, the line intensity also increases. So we'll take 0 energy level. So here degeneracy equals to 1. So what is the principle to calculate degeneracy? 2j plus 1. Okay, so this is 0, sorry, j into j plus 1. So this is 0, and here for energy number 1, then degeneracy is 3, for 2 degeneracy is 5. So as degeneracy is increasing, the energy level, the intensity of spectral line also increasing. And another thing, we have a Boltzmann distribution constant. So according to this constant, if the energy is increasing, the population decreases. If population decreases, the intensity of spectral line also decreases. So up to 3 up to 3 energy level, the energy is the intensity of line is increasing. From 4, 5, 6, since the energy of these levels are high, the population will be low. So because of that reason, the intensity will decreases. So for intensity of spectral line, we have two concepts. The first one is degeneracy, the second one is the Boltzmann distribution constant. Though in the rotational spectroscopy, the spectral lines looks like this. The middle line of energy 3 will be having higher intensity because of degeneracy of 7, and remaining 4, 5, 6, the degeneracy decreasing, sorry, the spectral intensity is decreasing because of the according to the Boltzmann distribution constant. As energy increases, population decreases, so spectral intensity. So this is the plot was between nj by n naught by degeneracy. So as we can see here, as the degeneracy is increasing, the intensity of spectral line also increasing. So according to the Boltzmann constant, so as the energy increases, the population decreases. If the population is decreasing, the intensity of spectral line also decreasing. So the principle what we have for rotational constant B equals to h by 8 pi square IC, and I equals to nu r square. Okay, so here we can see I is directly proportional to the reduced mass, B is inversely proportional to the this is rotational constant, and this is the moment of inertia. So rotational constant is inversely proportional to the moment of inertia. Okay, so when we have a molecule like we have a X type molecule, so if we replace this X by its isotope Ax dash, imagine that X dash is the isotope of X, and in this case there is no change in the bond length. So this bond length will be same, and this bond length also will be same. So in other words, we can say that there is no change in the intramolecular distance. The distance will be same, but the mass is decreasing here. Sorry, mass, it can decreases or it can increase also. Imagine that this is a chlorine 35 and this chlorine 37. Okay, if it's a chlorine 35 and 37, what is happening here? The mass is increasing from here to here. Okay, so nu is less than nu we can say nu bar is the isotope of this Cl37. So the mass is increasing. So when the mass is increasing, so the moment of inertia also increases and the rotational constant decreases. So when we have a heavy isotope, these points are important. In that case, mass increases and moment of inertia increases, then rotational constant decreases. We have a separation between lines. Next one, spectral distance. So these two we will talk now. So when we have a the spectra like this, okay, upon if the isotope is heavier, we know the spectra will looks like this. And see the distance here, the separation between these two energy levels, and here we can see the separation between these two energy levels. As we can see in both these cases, the separation is decreasing upon introducing the heavier isotope. The separation is decreasing. Okay, the separation will decreases. And what about the spectral distance? So spectral distance is nothing but like this distance. This distance also decreases upon introducing the heavier isotope. So this is about heavier isotope. So when we introduce heavier isotope, in that case the reduced mass increases, moment of inertia increases, the rotational constant decreases because rotational constant is inversely proportional to the moment of inertia, and the separation between two lines, as we can see here, is decreasing, and the spectral distance also, as we can see here, it decreases. Now when we have a lighter isotope, so lighter isotope, in that case the moment of inertia decreases, sorry, the reduced mass decreases and the moment of inertia decreases, the B value increases, the separation between two lines increases, and the spectral distance also increases. And this will be in the reverse way like this. Okay, the separation will be increasing here, compared to this, the separation will be more in this case, and the spectral distance also will be higher in this case upon keeping a lighter elements. So I hope it's clear what is isotopic effect. So when we have a heavy isotope, how it will be changing, when we have a lighter isotope, how it will be changing. I hope it's clear. And then we have a one principle like when we have a imagine that B equals to, we know this one, h by 8 pi square IC. Then b dash is the moment rotational constant of isotope, that will be h by 8 pi square I dash c. So now this will be, we can write this one, b by b dash equals to I dash by I, and this will be nu dash by nu. So this principle you have to remember. So this is coming like I dash by I equals to nu r square by nu r square. So this get cancelled, so this will come, and nu dash by nu, this is coming. So this is important while calculating the problems. So this principle we have to remember. So we have a problem here, the spacing between a rotational line is of HF is 40 centimeter inverse. So what about the DF? So we have to identify for DF. So this principle we have to take, B by B dash equals to nu dash by nu. Okay, now the spacing between these two lines. Okay, so we know that the energy difference between the line will be 2b, right? We can like the energy difference is 2b, right? So now 2b equals to 40 centimeter inverse. This is for HF. Now we have to identify 2b bar, this is for DF. Okay, so now we'll keep these things here. 2b by 2b dash is equals to nu DF by nu HF. Okay, and if it goes this side like this, and 2b bar is equals to nu HF into 2b by nu DF. and after that we have to identify new HF. This will be M1 M2 by M1 plus M2. So M1 will be hydrogen, M2 will be fluorine. So this will be 1 into 19 by 1 plus 19. This comes out to be 19 by 20. And for DF, new DF is equals to 2 into 19 by 2 plus 19. This comes out to be 38 by 21. Okay, so as we can see this one, HF by TF, this we can almost, this is equals to 1 by 2, because 19 twos are 19 twos are 38, means almost equals to half, right? So this we can write in this way. Okay, so this whole term became 1 by 2, and the 2b value we know that is 40. So 2b dash is equals to 1 by 2 into 40. So this will be 20, and 2b dash is equals to 20 centimeter inverse. So the rotational constant, the spacing between these two lines for DF is equals to 20 centimeter inverse. So just now I explained that if heavier atom is there or heavier isotope is there, what will happens, the space between two energy levels decreases, right? So we have proved this one by experiment, like in the mathematically also. The spacing between two energy levels for HF molecule is 2b. So here we have replaced hydrogen with a heavier atom, that is a deuterium. So the energy level, the energy difference between two energy levels are 20 centimeters. So that means it decreases. Okay. So next question we have, the first rotation line for carbon monoxide appears at 3.84 centimeter inverse, and where will be the third rotation appears. So what is the first line meaning? So when we have a 0, 2b, 6b, then 12b, the first line means from here to here. So the first line means E1 minus E2. The first line is equal to 2b. The second line means E2 minus E1. This will be 6b minus 2b, that equals to 4b, like that. So the first line 2b is equals to 3.84. Now b equals to 3.84 by 2. It comes out to be approximately 1.92. Okay, now they are asked about third line. Third line equals to 6b. So we can directly calculate 6 into 1.92. This will be a 11.50. 1.92 into 6. 6 2s are 12, 6 9s are 54, 55, 6 1s are 6. So 11.52 centimeter inverse. Okay, so this is simple for problem only, and the first line means 2b, second line means 4b, third line means 6b, fourth line means like that. Okay, so till now if you have any problems, like you have not understand anything, you can write in the comment box. Definitely I will solve it, and thank you.